Okay, so I'm on 2.8, and I was asked to go over B here. Now, this is from the normal distributions chapter in Practice of Statistics. This is the practice test at the end. Problem says that a fast food restaurant has just installed a new ketchup dispenser for use in preparing its burgers. So, we know that to start out, we have a mean of 1.05, standard deviation of 0.08. Now we're going to jump to part B. It says, suppose that the manager adjusts the settings so that the mean amount of ketchup dispensed is 1.1. How much does the ketchup standard deviation have to be reduced to ensure that at least 99% of restaurants' burgers have between 1 to 1.2 ounces of ketchup on them? All right, so we have a new mean now of 1.1. We don't know the standard deviation. I'll show you my first step here. I drew a normal distribution. I like to work with that. I know I want 99% of my data to be right here in the middle 99%. I want to go from 1 to 1.2 ounces. This is ounces. I'm going to label that just so I don't get confused. Now, if there's if there's 99% in the middle, that means I have 1% left, and I split it up, 0.5% on each end. Now, I don't know what the standard deviation is, but what I'm going to do is I'm going to work with z-scores. So I know a z-score of 0 for my mean. Standard deviations, they always go up by 1, but I don't know what the standard deviation is here. I really don't. That's why I'm trying to figure it out. However, I can use inverse norm to figure this out, which is what I'm going to do. I'm going to go with inverse norm. I'm going to enter in my area or my percentile, which is 0.005. Mean of 0, standard deviation of 1, because I'm just dealing with z-scores. I want to do with z-scores first. That's something I can work with. And notice I'm going to label stuff. Mean, nope, area, excuse me. Always label. Mean, standard deviation. And if I plug this in, which hopefully you did too, you get negative about 2.58. So I know the z-score that's going to get me to that 0.5% here. So that's good. I know the z-score for that for 1 ounce of ketchup. So what I'm going to do now, follow me. I'm going to use my z-score formula. I know a z-score of negative 2.58. I've got what I observed, my 1, right? Minus my mean of 1.1. I don't know my standard deviation. So if I just do some algebra, which hopefully you guys are comfortable doing the algebra end of this. I'm not going to walk through the algebra too much. But what you get is if you plug this all in, for your standard deviation, you get 0.0387. So for the sake of what we're doing, I'm going to go to 0.04. So that has to be my new standard deviation if I want to be getting 99% of all that ketchup going between 1 to 1.2. And then the last part of it just says, how much does the standard deviations have to be reduced? Well, if the original one is 0.08, the new one's 0.04, that means I just have to reduce my standard deviation to 0.04. This is a tough question. Again, what I just did was I drew a normal standard deviation. When in doubt, I did that. Represent the 99% I needed. I did not know standard deviations, but I knew what the data points were that captured that 99%. So I used z-scores. I worked backward to trying to find that z-score to capture that percent of data. Once I found that z-score, I was able to plug in the z-score formula and get my new standard deviation. Hopefully this helps you if you were stuck on this question.